Hi, welcome to another Houdini training session. My name is Gianvito Serra, and today we're going to be looking into groups inside of Houdini. Okay, groups are a very important concept of Houdini. It will be your first entrance into being able to do operations into smaller subset of components. Okay, so far we have seen how we can create digital assets and generate data and operate on the data as a whole. What we're going to learn today is how you can actually use groups to operate on the data in such a way operate on the data based on a certain selection set, if you will. If you're coming from Maya, you're probably familiar with the concept of selection sets. This is really not that different from it, and just like selection set, groups are sets of components of a geometry, like a set of faces, set of points, set of vertices, etc., etc. Okay. So just to show a little bit of how they work, we're going to go ahead and create a geometry node. Okay, and we're going to dive inside. Okay, groups are sensitive to the geometry context. Okay. There you go. So I'm going to go ahead and actually start with a sphere for this exercise, and just to show a little bit of what groups are. Okay, so I'm going to create a sphere, and I'm going to switch it from a primitive sphere to a polygon mesh. Okay, which looks like this. So groups in Houdini allow you to say, okay, I only want to be able to work on, say, for example, half of a sphere, or I only want to be able to work on these points over here. Okay, and there's multiple ways to go in about doing groups, but what a lot of the groups operations will be centered again in a main operator called the group sub, as in group of friends, if you will. Okay, and the group sub takes the two inputs. The input on the left is the one that we're going to focus on for now, which is the source data, the source geometry to actually create a group for. Okay, so when we highlight it, okay, you will notice that right now it doesn't look like too much is happening here. Okay, but if we actually put the select tool here, you will notice that all my faces are actually selected all of a sudden. They look like they're actually highlighted in some way. Okay, what this is actually doing is creating a group on my geometry called group 1, which is of primitive types, and is basically set to select every primitive in my object. Okay, so if we middle mouse on the group node, you will notice that now I have a new section in here. Okay, which is that I have one primitive group which has 288 primitives in group 1 in this particular case. Okay, very cool. Now you will notice that as I disable this and re-enable this, the actual group, my group membership actually changes. Okay, here it is. Actually, we can see better. You actually have to have the handle selected, not the selection tool. But so here we can actually see that by disabling and enabling the group, we can see the faces being added to the group and not in the group. If I disable this and I middle mouse on this, you will notice that now the group doesn't exist. If I enable it again, you notice that now the group exists. Okay, very cool. Now the group can be named anything we want. So instead of calling it group 1, we can call it, for example, all primitives. Okay, and if we middle mouse, now I have a group called all primitives. Okay, which has 288 primitives, all of them. We can make that group primitives, but we can also, for example, make it points. Okay, and now I have a group that selects all my points, and I can call it all points. Okay, if I middle mouse now on the node, you will notice that now I have 266 points in all points. Okay, now obviously selecting every single point on the mesh is not super useful. So the group operator has many different things that we can do to do selection in a deterministic fashion. So for example, we could say select every point that goes from 0 to 100. Okay, and now you will notice that not all my points are selected. Okay, only the points that are on the top are selected, right? If I switch this back to primitives, you will notice that now only my primitives that go from 0 to 100 are selected, and the ones here are not. All right. And just to illustrate that, we can come here and actually show the primitive numbers, and you will notice that all the primitives that are less than 100 and 100 are actually highlighted, and the primitives that are down here are not highlighted. Okay. Say, for example, I wanted to change this number all the way up to 146. Okay, so if I change that to 146, you will notice that now my selection includes all the numbers that are out of 146. Okay, very cool. So what can we do now after we have that? So, well, say, for example, I wanted to extrude those faces. Okay, and then if we go to an extrude operator, or actually, sorry, if we drop a poly extrude operator, and we actually extrude, you will notice that by default it extrudes the whole the whole polygon sphere, right? But most operators in Houdini will have on the very top here something called a group field. Okay, and in the group field you can actually come to you can actually specify the group that you want to only apply this modification to. So for example, if we click on this drop down over here, you will notice that I have multiple choices that I have here, and one of my choices is actually the group that I created called all points, which, since I switched it to primitives, I'm actually going to switch it back to all primitives. Okay, or actually I'm gonna say, like, I'm gonna rename it to some primitives. Okay, and then I'm gonna come back to my poly extrude node and change this to only operate on some primitives. And now you can see that the extrude operation is only operating on the primitives that are inside of that group. Okay? As we add more or less faces to the group, you will notice that more or less faces get added to the extrusion that we see here. Okay? Unlike most applications, groups in Houdini are as procedural and as persistent as any other operation. Okay, so the selection that you create out of a group operation will automatically adapt to match whatever is incoming in the actual network. Okay, so if I come, for example, here and I adjust the sphere dimensions, and then maybe even adjust the number of rows and columns, and I go back to my group, you will notice that my group has updated to match the IDs. Okay, if I select the sphere, and I'm gonna go ahead and pin the UI here so that the UI of the sphere stay put while I have the group selected, and I keep adding rows and columns, you will notice that faces keep getting added or unadded depending on the IDs of the faces that we are creating. Okay, because remember, we're only adding faces from 0 to 140. Okay, likewise, if we go back to the poly extrude, you will notice that only the faces that match the criteria that get added to the group are the ones that are getting extruded from my extrude operation. Okay, so in short, and we are going to look more into how some of the things that we can do here, but in short, a group operator is, or a group in Houdini is basically a means for anybody, for a user to make an operator work on only a subset of a geometry as opposed to the whole geometry. Okay, and it could be points, it could be primitives, it could be edges. Okay, which we can see, let me unpin this, which we can see on the drop down right here. Okay, very cool. So now we know a little bit about this, we are going to do an exercise. Okay, and this exercise is going to be to make a text generator digital asset. Okay, so we press tab. I'm going to bring in my text generator to show you. What we have in here is a text generator digital asset which generates 3D text. Okay, we can come in here and say and change the text on the fly. We can, adjust, for example, the font size. We can adjust the whether we want it to be italics or not. We can even adjust the extrude depth. Okay, but the thing that you will notice is that our bevels are happening only on edges with certain criteria. Okay, you will notice that also I'm able to modify the front face colors different than the back face colors. Okay, and that's because we're able to use groups to isolate where some of these operations are actually happening. Okay, with that said, let's go ahead and get started. Okay, so we're going to go ahead and start first with a font operator. Okay, and we'll put the focus on this. The font operator you saw on some of my previous tutorials, and what it actually does is that it allows me to create geometry matching true type fonts. Okay, so in this operator I'm able to do, for example, put any font I want, that I have here, and be able to drive geometry that way. And you can even use expressions and variables to, for example, drive the actual text that we have here. Okay, so we'll start by simply just going with our Helvetica and put in the text cool text, just like this. Okay, very cool. So here is our 3D text and here is our cool text. Wonderful. Cool. The next thing we're going to do is to actually drop a facet node. Okay, the facet node is going to allow us to as you saw before, remove inline points, or points that are actually not contributing that much to the actual contour of our meshes. Okay, so yeah, if we look, for example, here, you will notice that we have a lot of points here which really are not doing too much to the actual contour of the mesh. So in the facet, we're removing line points on, allows us to clean that a little bit more. Okay, very cool. You can definitely see it on the T here, where it actually really cleans out the T. Okay, very cool. All right, the next thing that we're going to do is to simply extrude our text. So we're going to drop an extrude sub. Now remember, this is not a poly extrude, it's an extrude because we're actually extruding curves. Alright, so here is our extrude for the 3D text. Okay, and everything is working like we want. Okay, we can adjust the depth scale here. We can still even go in and change the font here, and everything works as expected. Okay, cool. Now the first thing that we're going to do, if we look at our existing operator, is that we want to try to get some bevels in there. Okay, and we want the bevels to happen on some of those hard edges. All right, so the first thing that we have to do is to actually find what those hard edges are, so that we can choose to actually bevel only them. All right, in order to do so, we're going to use our first group sub. Okay, and by default the group will be set to select all primitives. Okay, and from there we can go in and start adjusting the settings so that it does exactly what we want. Okay, so we're going to first change the name of a group to something that makes a little more sense. Like in this case, I want it to be sharp edges. Okay, and I want my group entity to go not to be primitives, but to be edges. Okay, so this is actually an edge selection that I have here. Okay, so for middle mouse, you'll notice that now I have an edge group and it has 2036 edges in sharp edges. Okay, which in this case is now every edge. Now, so we need to put some logic in there to be able to filter out how many edges we have selected, okay? We can simply do that by going under some of these tabs here to actually find some different options. But the first thing that I want to do is to turn off the enable number, okay, which groups everything. This makes it so that I group absolutely nothing. So we have a completely nothing in the group, okay? If we look at some of these tabs, we have multiple options that we can use in here to actually do grouping, okay? And you will notice that there is actually an edge tab, okay? The edge tab is where we can actually do things like, for example, group edges based on like the edge length, the edge angle, etc., etc. So in order to do this, what we're going to do is turn on enable the edge tab, okay? And we're going to turn on the minimum edge angle, okay, which is right now set to 20. And you can immediately see that we actually now have a group of edges, which are the edges that basically have a minimum edge angle of 20 in between their primitives, okay? So that's a great start. It's selecting a few edges that we don't want. So we're gonna adjust this to something maybe like 85, okay? Or maybe a little bit less, maybe we'll go with 60, okay? So that it picks up these ones over here on the obliques. All right, so I think that works a little bit better. Cool, cool. So now that we have a group of edges, we can now use a bevel sub to actually bevel only those edges. So if we press tab, but wait, before we do that, one thing to notice though is that the edges that actually are here, that separate the actual profile from the face, are actually not getting selected. Well, the reason why that is because by default, the extrude node does not consolidate the front faces with the back faces, okay? But we can fix that by simply turning on consolidate face to mesh. Okay, so when we turn that on, now watch what happens. Immediately you will notice that the shading looks really strange, and that is just because the extrude sub is now merging the points around the boundaries so that they are connected, okay? So if we look at the point numbers, we have one point number here. If I turn that off, then I have two numbers here, okay? So we want to consolidate it right now because of what we're about to do, okay? So now we go into the group operator, and now you will notice that now my group includes not just the edges that are hard on the corners, but also the separation in between the face, front face, and the side face. Very cool. You can probably see this a little bit more clear if I even go to hidden line invisible, and you can kind of see it a little bit better there if you can see. Okay. Cool. Now the next step is to go to the bevel operation. So we go poly bevel, and then we turn that, we activate that, and then by default, obviously, the bevel is not going to do exactly what we want. We're gonna, for one thing, the bevel is actually operating on points, which is not what we want. So the first thing that we need to set it is to work on edges. Okay. So the next thing the poly bevel is going to do is that it's going to try to operate on all the edges, and we don't really want to do that. We also don't want a relative inset. We want it to only operate on some of the edges and to do it by an absolute value. Okay. So we'll give it about 0.1 or so. Maybe that's too much. 0.01. Okay. So that's about right. But we're still not quite right because you will notice that we're still getting a lot of edges beveled that really shouldn't be beveled. Okay. So that's where our group can really help us, and we want to. So we want to actually switch these to sharp, only doing sharp edges, and now you will notice that only the sharp edges are getting bevel, and the other ones are not. Very cool. Just a few more changes here. I want to actually switch these to high density wrap. Okay, and now we have a bevel that is fully deterministic and only happens on primitives that have, you know, a 60-degree angle in between them, okay, which is exactly what we wanted. Wonderful. Okay, so this is a probably good first example of some of the things that we can do with the group operations. Okay, so moving forward though, The next thing that we need to do is that we need to clean up all the ugly triangulation that we have going on here, okay? And fixing this is very simple. There is actually the divide operator, which allows us to clean polygons, to triangulate primitives, so that they basically turn into convex polygons, okay? Now this is merely just trying to enforce convexity and not trying to do a pretty triangulation. The best way to do that is to turn off don't generate slivers and lose my angle, avoid small angles, and that will give us a clean triangulation on the mesh, okay? We will notice, however, that we're also triangulating the back faces, which I really don't want to do that. You know, I really like to keep those not in quads, just because I want to keep them. They're already quads. I know they're quadrilaterals, right? So we need to be able to only operate on the faces that are front faces, right? So we're gonna need a group for it. So the best way to do that is to, before the divide, use another group operator, okay? And set this group operator to be in front primitives, okay? We're gonna leave it at primitives, of course. And when we go, but we're going to turn off enable, and we're going to use the normal section of the group, okay? Inside of the normal section, when we enable, you'll notice that we can actually group primitives or points based on how their normal is facing, okay? So in this case, I wanna grab every primitive where my primitive normal is facing forward, okay? It's a little bit hard to tell here, but the front these primitives are obviously facing forward, okay? So to do so, we actually want to make sure that this is set to 0, 0, 1, which is positive C, okay? Which is already actually, but you'll notice that regardless of that, it's still selecting every single primitive around it, okay? Which is not good, but that's because our spread angle is set to 180, okay? So it's doing a full, looking at primitives that are pointing forward, or normals are pointing forwards, and then going on a full circle and finding anything that is within a spread angle of 180. If we actually reduce that, you will very quickly notice that now we're actually limiting the selection to only the front faces. Right now the bevels are also selected, but I actually don't want the bevels in there, so we can go even lower, and then eventually we get only the front faces, okay? Few little triangles made it. We can probably go even lower than that. In reality, we should be able to go to something like 1, and that will select absolutely only the faces that are facing the front, okay? So now that we have that, we can go back to the divide sub, and then switch this from operating on every primitive to only operate on the front primitives. Now, very cool. Now you will notice that I have a few options here, okay? I can do front primitives. I can also click on this, and you'll notice that front primitives has a little star by it. So I can click on that and actually erase my selection there. And now I get all the primitives again, okay? You can even do things, for example, like type in front, pre, and then put in a star, which will basically use a wildcard to find any groups that match this particular string name. So front pre in this case, okay? So remember that you can use a lot of different methods for creating groups other than just explicitly typing the group name, okay? You can do this, you can do, we're gonna learn a lot of very different ways so we can actually create groups using wildcards and things like that. But this is actually a good one that I wanted to show. You'll notice too, if you go to the drop-down menu, that there is from primitives, but then there is also group to primitive selection, okay? What is actually, when you do that, it selects it from faces, but you'll notice that instead of actually having the group name, I end up with the IDs of the faces that are inside of that group, okay? That's something that normally you shouldn't do if you're trying to make a digital asset or a procedural system. I always recommend using the actual explicit group names, okay? So in this case, I'm gonna erase these numbers, and I'm gonna switch to using the group name from primitives, okay? Very cool. Now, say for example, at some point, you feel like you wanna change that name to something more like from polis, okay? You will notice that now all of a sudden this broke, right? And you even get a warning here. If you look at the warning, you will notice that it's saying that there is an invalid group from primitives, okay? Well, that is because from primitives doesn't exist anymore. It's now called from polis, okay? So you can come obviously in here and fix it by just fixing that, okay? You can even do front star and that will fix it, okay? But a good way to also fix that, and a good habit to do, is to instead go to the group name and say copy parameter, and then come to the divide sub, and then go to the group field here and say paste copied relative references, okay? So that creates an expression that makes the group field match. If you middle mouse on the label, it makes the group field match the name of a group from polis. So if I come here and change this back to from prims, you will notice that everything still works because my expression is keeping the name the same. Very cool. Great. So now that we have the front faces, as you can imagine, this is very easy, right? We can actually piggyback on the fact that we have that group and actually add a color operator and simply add the group that I want to color. I just want to color the from primitives, right? So that is great. Now I can color my from primitives whichever way I want, which is awesome. And everything is great. But one problem that we still have though is that we want to be able to also color the back faces, but a different color than the front faces, okay? So we can get very fancy and try to come up with a way to procedurally find faces that are not facing forward, okay? But to show you how we're gonna do this, I'm gonna show you how you can use the group sub not to create a group, but to modify an existing group, okay? Like I said, the group sub is a hub for doing all sorts of group operations. So it's nice to actually have a lot of these things in one place. What we can do is basically put another group sub after the color. Okay. And in this case, what I'm going to do is that I'm going to call this group side faces. Okay. I'm gonna turn on enable error. Actually, I take that back. I'm not gonna call the group side faces. I'm gonna just keep an empty group sub and I'm gonna turn off group name. Okay. So what I wanna do is that I don't wanna create any group. I want to just use the group sub and turn everything off so that the group sub does absolutely nothing. And you can see it's not creating anything new, okay? So once we do that, we're going to go to the combine tab on the very top. And we're going to use this section to actually create a new group based on groups that already exist, okay? Think of this section almost as a way to do Photoshop type operations in between groups. So one thing that we can do, for example, is to create a group based on all the faces that are not part of this group by saying group side faces, okay, is equals to, this is equals to, or not equals all but, so we're gonna set equals all but from prims, okay? So here we go, cool. So what this is doing now is that it's actually making it so that the front primitives, and any face that is not on front primitives is gonna become a side face. Okay? Cool. So this is what works in such a way that if I come back to this and I adjust my spread angle, you will notice that the group will update on the fly based on the other group. Okay? Very cool. So now that we're gonna go ahead and call it side prims to keep it consistent. So now that we have the side prims, all that we need to do is put another color operator. Okay. But then we're gonna make this one operate only on the side prims. Okay, I want to make sure that this is set to primitives. Okay, I'm going to set the color to, say, for example, green. Oh, and I also need to make sure that I change this one to primitives as well. There we go. Because we want the colors to be on the primitives, not the points, since we're actually using a primitive group, not a point group, okay? So here we go. Now we can change the colors in the front face, separate from the colors on the back face, which is very cool. We can even create an expression which makes the color of the back just a little darker than the color of the front. We can do that by copying this color and pasting it here. So paste, copy, relative references. So now they're the same. And all that we do is just basically multiply that by 0.5. Multiply by 0.5 and multiply by 0.5. So what's cool now is that when we change this color, the tool will automatically color the back a darker color than the front. Very cool. But in this case, I'm gonna go ahead and break my expression because I wanna be able to control the back color by hand instead of that with an expression. Okay? Awesome. Well, at this point, we actually have the whole thing together. Now we just need to create a digital asset. So we're going to put an output node. Okay, and call it out. And we're going to go ahead and make it blue. We're going to go ahead and grab our first node and actually make it yellow. Okay. I am not going to name my nodes for now. I already did this on this one, but just to actually because just for the sake of reviewing how to make a digital asset, we're going to go ahead and make one. Okay, so we're going to select all of this and we're going to put them into a subnet. Oops. And we're going to create a digital asset like we did before. Okay, so we're going to call this one the 3D pets generator. Oh, this is my pretty name. I forgot. 3D text generator tutorial. Okay, I'll go ahead and change the name here. Now watch what happens when I hit accept. I get an error saying that the name must start with an alphabetical character. Okay. One limitation that we have with operator type names is that they do need to actually have numerical. They cannot have numeric numbers as the first letter of a name. That's a very typical thing that happens in a lot of applications. So for the purposes of this, what I'm going to do is to simply, I can leave my label the same. I can say text generator 3D tutorial and hit accept. Okay. Okay, so when we hit OK, we go to the type properties window and we can start promote parameters that we feel are relevant to generating the 3D text, such as, of course, as you can imagine, the text that we're gonna need. Okay, although that we're gonna make in 3D. Make this a little bit smaller so we can see a little bit better. Here we go. So the text that we wanna, make in 3D, the font that we're gonna use for the text. Okay. Notice that the font parameter is actually called file because it's actually referencing a text file. So we're gonna call it font. And then also probably the font size, the oblique angle, which is actually like the italics, and the level of detail. Okay. We can also promote the extrude amount, the depth scale. Okay. Very cool. And then perhaps we can even promote the bevel amount. You see, this one I will probably provide a small range just so that we don't get into situations where the bevel can break. So maybe go to 0.05 and set. Actually, wait, and then obviously, before we forget, we do want the colors to control the front and the color to control the back, which will appropriately name front color, and back color. Now I'm gonna hit accept. And here is our digital asset. The first thing that you will notice though is that the text from the actual font looks like a very large parameter, and that's because really you can actually come here and do multi-line text. Okay? But for the purposes of this class, I do want it to be single line. So I can go right click on this and go again to the type properties at the very bottom and click on the text and switch it from being a multi-line string to being a single line string. And I'm gonna hit accept. Now the text is now single line. And we only have one line here, okay? Next, you can go in here and if you like, put some separators on the actual UI. And then just to clean your UI up a little bit. But this should give us all the controls that we need to do the kind of things that we want to do. Okay, so there is a level of detail control, for example. There is our depth scale for the extrusion, or oblique angle if we wanted to actually make it more italic. And you will notice that everything still automatically tessellates, triangulates, everything that we want. We can even pick a switch fonts to Arial, for example. We can do really anything we want with this particular text generator. Okay. We can even come in here and adjust the bevel to see if we want a little bit less or a little bit more bevel. But that's just basically all the controls that we have from our digital asset. Very cool. All right, this should be it for this particular session. Oh, before we go, don't forget to save your digital assets. Right click on it and say save operator type. And then right click again and say match current definition. Okay, so now this is actually saved to disk. All right, well, thank you for watching, and we'll see you on the next tutorial.